Okay, today we're going to kind of put what we've been working on, put it all together, and talk about converting from moles to mass and mass to moles back and forth into something that we can actually use in lab. So if you were there on Friday, when we did part of the ornaments project in lab, I kind of explained afterwards how I made those solutions that we use and how knowing molar mass and how to convert between moles and mass allowed me to make two solutions that were the same concentration. That way we weren't wasting any of our reactants. So we're going to do that process today with a bunch of these practice problems and kind of get you guys used to it. That way when we go back to lab and I ask you questions about it, you can make your own solutions and you kind of get the concept of going back and forth between mass of a substance and how many actual moles or molecules of that substance that would be. Okay, so the main idea here, there's basically 3 steps to it. So we'll do probably 2 or 3 of these as an example, one from each type and then maybe one more of the more difficult ones. But basically for all of them you're going to be following the same couple of steps. So let's look at number 1 to start off with. So number 1 here wants you to take the mass that it gives you and convert that into a number of moles. So what it's given us is 30 grams of a substance, and then it gives us the chemical formula of that substance. So it tells us that it's H3PO4. And we're trying to figure out how many moles of hydrogen phosphate that would be. So if I go over to the paper here, your first step in any of these problems where you're going from mass to moles or moles to mass, either direction, doesn't matter, is going to be to find the molar mass of the formula of what it gives you. So that's what y'all were doing last week. So it should be pretty familiar to you. Remember, you're going to find the atomic mass of each of these elements that's in it. So we can do that by using a periodic table. Let's turn that on. So we'll find hydrogen first. And on these ones, what I want you guys to do is just use the mass to the nearest whole number. You don't have to worry about all those decimal points. Just round it to the nearest whole number, and that'll be close enough for what we're trying to do today. Okay? So for hydrogen, the nearest whole number to its mass is going to be 1. Okay, then we've got to go and find phosphorus. So its mass is 30.974, so we're going to round that to 31 would be the nearest whole number. Okay, and then oxygen over here, its mass is 15.999, so that will be 16. Okay, so once you've found the mass for each element, you're going to go ahead and multiply each of those masses by how many of the element are in your formula. So for hydrogen, it has the subscript 3 right there, so that means we have 3 hydrogens in the formula, so we're going to multiply by 3. Phosphorus doesn't have a subscript, right? There's just 1 P, so it just gets multiplied by 1. And then the oxygen has the subscript 4, so that tells us that there are 4 oxygens. So we go through, we multiply those, so 1 times 3 is 3, 31 times 1, 31, and then 16 times 4 comes out as 64. Okay. Your last step for finding the molar mass of this formula is to add them all together, and that gives you, let's see, 3 plus 31 is 34, plus 64 would be 98 grams per mole. Okay, so on every single one of these problems, your first step is going to be doing this process here to find the molar mass of whatever formula it gives you. Okay, then your next step is going to be setting up dimensional analysis and they'll be real simple. These are all just going to be one step aside from, I think, 2 problems on there. And using this grams per mole that you found as a conversion factor. So if we start setting it up using what they've given us, our 30 grams, we can say 30 grams of H3PO4. And then our next little step in our dimensional analysis problem should be using this as our conversion, right? We know it's 98 grams per 1 mole. So if we're going to set that up as a fraction, we just need to decide which side of this fraction the 98 should go on. And if it's grams on top here, it's got to be grams on bottom over here. That way they cancel each other out. So we put 98 grams on the bottom per 1 mole on the top. And then our units cancel each other out. So we have grams and grams canceling each other out, leaving us with only moles as a unit, which is what we're looking for. So, like I said, real simple, it's only one step. You multiply everything on top together, which is just 30 times 1, so that would be 30. Everything on bottom is just the 98, so the bottom is 98. And your answer is going to end up being 30 divided by 98. Alright, so in general on these problems, you're going to be taking the mass that it gives you divided by the molar mass will give you your answer. But it's a good practice to set up these dimensional analysis parts, because there are a couple problems in there that are going to have multiple steps, not just the one division. So you want to do this just to kind of keep yourself in practice of how you would set it up. So here, 30 divided by 98. I don't know that one off the top of my head. So let's pull up a calculator. And we would say our answer for number 1 is that there are 0.31 moles. Okay. So for all of these problems, remember when you're doing the masses of the elements, round those to the nearest whole number. And then when you get your final answer, I want you to round that to 2 decimal places. So that one was 0.3061 blah blah blah, and we rounded that down to 0.31 moles. Okay. So that's going from mass to moles. The other direction, it's a pretty similar process. So let's pick one of these to do as an example. We'll probably just do number 9. Keep it nice and simple. So this time, it's telling us that we have 4 moles of copper cyanide. And it wants to know how many grams that would be. So how much is 4 moles of copper cyanide going to weigh? Okay, so just like the other one, your first step is going to be finding out the molar mass of copper cyanide. So here we're going to take copper, carbon, and nitrogen, and we're going to go and find their masses on the periodic table. So let's look around and see if we can find copper. There it is. So its molar mass is 63.546. So we're going to call that 64, which is the nearest whole number. Okay. Carbon is 12.011. So that'll just be 12. And then nitrogen is right next to it. Excuse me. And it is 14. Okay, so we found the molar masses. Now we have to multiply by how many of each of those molecules or atoms there are in this molecule. So if we've got copper, there's no subscript there, and it's outside those parentheses, so that doesn't apply to it. So for the copper, It's just 1. Okay, both the carbon and the nitrogen are inside this parentheses, so whatever their subscript is in here, however many of them there are inside the parentheses, gets multiplied by this number on the outside. There's 1 of each inside the parentheses, so 1 times 2 for each of them is going to be 2. So we have 1 carbon, 2 coppers, 1 copper, 2 carbons, and 2 nitrogens. Okay. So we multiply those out. 64 times 1 is 64, 12 times 2 is 24, and 14 times 2 is 28. And then add them all up. So here we've got 116 grams per mole. Yeah, pretty sure that's right. Alright, so that step we're done with. And then this time, when we set up our dimensional analysis matrix, we're going to start with moles, because that's what's given to us in the problem here. So we're going to say 4 moles as our first little part. And then our conversion factor, this fraction here, is going to be this molar mass that we just found. And this time, because the moles are on the top over here, they've got to be on the bottom in this fraction. So we're going to say 1 mole, and it's 116 grams per 1 mole. Okay, so moles cancel with moles. That might be confusing the way I've written that because I abbreviated one of them, so let's fix that. So moles cancel with moles, and then we multiply everything on top together, which is 4 times 116, which is 464. And then everything on bottom is just the 1, so it's 464 over 1, which means that 4 moles of copper cyanide are going to weigh 464 grams. Okay, we didn't need to round that one, there's no decimals, so it makes it nice and easy. Alright, so that's the main idea of what you're doing. There are 2 problems on here that are a little bit more involved than this, because they ask you to convert to or from customary units. So we'll do an example of one of those, and then the rest of them I'm going to leave to y'all to work through. So the last one we're going to do together, the trickiest one I think, is probably number 7 would be the trickiest. Well, no, let's do number 8. Alright, so on number 8, we have 5.6 ounces of lead C2H3O2. Alright, so that's a big old, it's going to be a huge molecular weight, both because lead is very heavy and because it's got a ton of these other elements in there adding to it. And what we're trying to do is convert that to moles. Alright, and just like the other ones, your first step, of course, is going to be to find the molar mass. So we're going to say we've got lead, copper, hydrogen, and oxygen are our 4 elements that are in there. And we want to know what the molecular weight, or the atomic weight, of each one of those is. So let's find lead. It's right here, down near the bottom. So it has a atomic weight of 207. Right, carbon, if we want to find it, we've used it a couple times already. Eventually you guys will get a hang for it, where you'll kind of know them off the top of your head, but use the periodic table until you get there. So carbon has a mass of 12, hydrogen is 1, it's the smallest one all the way over here, and then oxygen is 16, right? We're rounding them all to the nearest whole number. Right, then we've got to go ahead and multiply each one of those by how many of them we have in the formula. So if we're looking here at lead, it's outside the parentheses, there's no subscript on it, so we just have the one lead atom. Carbon gets a little trickier because it's in those parentheses right there. So there's 2 in the parentheses, and then outside there we have the 4. So we've got to multiply whatever is inside by what's on the outside. So 2 times 4 means we have 8 carbons total. For the hydrogens, there's 3 inside times the 4 on the outside for a total of 12 hydrogens. And oxygen is the same as the carbon. 2 inside times 4 on the outside gives us 8. So then we'll go through and do these multiplication steps. 207 times 1 is 207. 12 times 8, going back to your multiplication tables from like middle school, is 96. 1 times 12 is just 12. And then 16 times 8, I don't know off the top of my head. So we're going to pull up our calculator for that one. 16 times 8 is 128. Okay, add them all together. So we'll do 128 plus 12 plus 96 plus 207 adds up to 443 grams per mole. Okay, so far this hasn't been any different from any of the other problems we've done. The trick on this one comes is that it gives it to you in ounces at the beginning. So when we set up our initial dimensional analysis matrix, we can't just go straight into using this grams per mole conversion because originally we were given ounces. So first we've got to convert between grams and ounces. So this is where you go back to that conversion chart you had on the previous homework. And I will link that for you again in this homework just for these two problems. But we're looking for a conversion between ounces and grams. So if we look, we can find right here, it says 1 ounce is equal to 28.35 grams. So if we're going to put that into our dimensional analysis, if we have ounces on top, it means ounces have to go on the bottom down here. So you've got 1 ounce is 28.35 grams. And now that we've gotten to grams as our unit of mass that we have, now we can use our conversion, ounces on bottom, grams on top, put it in, and now we can use our grams to moles conversion that we know from this to figure out how many moles we have. So if grams are on top right here, that means they've got to be on the bottom in the next step. So we'd say 443 grams per 1 mole. And then all of our units cancel out. We had ounces on top, canceling with the ounces on bottom, grams on top, and grams on bottom. So we're left with just moles, which is what we want. So multiply across the top, which is 5.6 times 28.35. And you get 158.76. And then on the bottom, you just have 1 times 443. So it's going to come out as 443. So then we'll plug that into our calculator as 158.76 divided by 443. And that will give us our final answer for the number of moles we need, or the number of moles that would be in 5.6 ounces of this chemical. And like I said, round to 2 decimal places, so this would be 0.36 moles. Okay, so that's what you're doing today. There's only one other one like that where you're worried about converting between metric and customary. The rest of them are going to be more simple like the first two that we did. Um, so that's what you're working on. If you have any questions, as always, just let me know and I will help you out.